Hi, let's start the new topic called as area and perimeter. So this comes under mensuration topic where these two are related to 2D measurement. That is, what is 2D? 2D is nothing but two-dimension measurement here. So we'll study this topic. Actually, whenever you hear this word mensuration, all formulas come into your mind. But here we'll study how the formulas have arrived. So that no need to by heart those formulas. So if you forget the formulas, you can try to recreate your own formula for your measurement. Okay. So first, before going to what is this area and perimeter, let me give in detail explanation of what is area and perimeter. Okay. So what is the area? The total space enclosed by the boundary of a plane figure. Plane figure. Plane is it is occupying only two-dimensional. That is, one is x direction and y direction. Then it called as plane. Then you see it here. These are the boundaries for this figure. This is one boundary. Boundary is nothing but which is closing this figure. So this is closing and this is closing this figure. This is closing this figure. This is closing figure. And this is forming an enclosed figure. And these are called as boundaries. This is one boundary. This is second boundary, third, fourth boundary here. And the total space that is enclosed by this boundary. So this is the space. This space is called area. Fine. So my approach here is, in order to cover this area, complete area, what I will do is, I will take only a stick called of length A. This is the stick, my stick. Stick means it has only one dimension, so it may have some length here. So this is the stick for me. And what is the length of the stick? This stick is A length. And I will take this stick parallelly towards in the vertical direction up to B times. So that it will cover this complete enclosed space. So I am least bothered about B here. I am taking only length A here, and I am taking parallelly. I will put like this sticks, A length sticks, one stick, two sticks, third stick, five stick. And how many sticks I have to keep it here? Of B distance sticks I have to keep it here. So what is the area formula here? How many A's are there? A plus A plus A plus A plus A plus A. So if you add all these sticks, it will cover this complete space. So that is like this. How many A's are here? A's are nothing. If you take A common, they 1 plus 1 plus 1 plus. How many ones are here? It has to cover B times. That is called as A into B times. So A scale covering B times will give you this space. That is the interpretation of this. Fine. If you check it properly, draw a diagonal for this. Now it is forming two triangles here. We came to know that the complete for this rectangle, what the area formula is? A into B. And you know why you got this A into B. Now I have divided into two triangles. So here the area of each triangle is, so it has to divide by 2 because it is covering two triangles. So now area of triangle is equal to half into A into B. What is A here? This is the base. What is B here? This is the height which it has to move. So always in the area of triangle, A is nothing but base, B is nothing but height, exact perpendicular height. Perpendicular. So we got this formula like area of this rectangle is equal to A into B, and area of triangle is equal to half into A into B. This is applicable for rectangle and triangle. Formulas for that. So no need to by heart this formulas, just create like this. Now go to the concept called perimeter. So peri means outer surface. Peri means outer surface. If we have pen like this, the outer surface, whatever is there, that is called as peri. And meter is nothing but measurement. Outer surface measurement. This is outer measurement is called as perimeter. So if you have taken rectangle here, it's only outer surface here. This is outer surface. This is called outer surface. And the length of border, only this border, is called as perimeter. If something is included here, this space is called area, and this outer length is called as perimeter. So here, if you see here, so what is the outer surface? What is the length of this outer surface? A. What is the length of this outer surface? B. And as this is parallel, again it is A. And this is parallel, again it is B. So what is the total length of this outer surface? A plus B plus A plus B. And you have to do it for the complete enclosed surface. So it becomes A plus B plus A plus B. 2 A's are there, 2 B's are there. So 2 into A plus B. So if you have a triangle here again outer surface A, this is outer surface A, this is outer surface B, this is outer surface A. And in order to find this, you have your starting point and the end point has to be same. So you are starting from here, going here, and again it is ending here. So that is the enclosure plane is called as perimeter here. Okay, so for this triangle it is A plus B plus C. Have you understood this concept called perimeter and area, and we will apply same concept for finding for the different triangles and different perimeters. Let me discuss this finding area and perimeter for equilateral triangle here. So what is the perimeter for equilateral triangle? You know equilateral triangle is nothing but all three sides are equal. Here A. So what is the perimeter now? A plus A plus A. So it becomes A plus A plus A. This perimeter is 3A here. And in order to find area for this, first thing you have to find its height first, because base is A here and height is, this is the height. This one you have to take. So in order to find it, you don't know about this length. Okay, but it forms a right angle triangle here. Okay, just consider this as a median here, and it is forming right angle triangle here. Okay, so this length A, as it is dividing here, it becomes A by 2 this side, A by 2 this side. Now apply for this right angle triangle, apply trigonometry like tan 60 degrees is equal to opposite side x divided by adjacent side A by 2. What is tan 60 degrees? Root 3, which is equal to x A by 2. What is x here? Root 3 A by 2 is, so the height here is nothing but root 3 A by 2. What is base here? A. What is height here? Root 3 A by 2. So now, what is the formula for a triangle here? Half into base into height. So half into, what is the base here? A. What is height here? Root 3 A by 2. So which is equal to root 3 A square by 4. This is for area of equilateral triangle. Fine. Now, if you take this as center, okay, and if it is touching all the three vertices, it is called as circumradius. Okay, and this is nothing but your radius R. So this is O. Let me call it. This is R. Let me take an isosceles triangle here. For isosceles triangle, any two sides are same. Let me take these two sides are same and this is not same. Now in order to find perimeter for this, perimeter is nothing but this plus this, which is equal to 2A plus B. 2A plus B here. Now in order to find its area, again we have base here. In order to find this, we require a height here. Again, so this is B. So let me take it as B by 2 this part and this as B by 2. Now I have to find this x here. Again apply right angle triangle concept here. This becomes A square is equal to x square plus B square by 4, whereas x is equal to square root of A square minus B square by 4. This is height here. Now finding area here is equal to half into, what is base here? B. What is height here? Square root of A square minus B square by 4. If you try to remember this formula, it becomes very difficult. So whenever you have just triangle, try to find height first, then do this calculation and find the area. So don't try to by heart this for isosceles triangle. Now if you have a scalar triangle, that is where all sides are not same, A, B, C. Now it is very difficult for you to find this area, because you cannot drawing here will give you different height here, because these are not same. Now for this perimeter is nothing but A plus B plus C. Whenever for scalar triangle, if you want to find area of triangle, you have the formula like if the perimeter is equal to 2S, which is equal to A plus B plus C, where S is equal to A plus B plus C by 2. For finding area of triangle, you have the formula called square root of S into S minus A into S minus B into S minus C, where S is called semi-perimeter, like half of perimeter. Substitute here, substitute A, B, C values, you will find this area of triangle for scalar triangle. And we don't require proof for this. If you are interested in finding the proof for this, just ask me in your comment box and I will reply for you. Okay. Let's find inradius and circumradius for equilateral triangle. We know in an equilateral triangle the angles are 60 degrees here. So here we will find in what is inradius. Inradius is nothing but the circle which is drawn with radius R inside the triangle. What is circumradius which is drawn with the circle which is touching outside that is vertex of triangle. If this is touching, this is called circumradius, capital R. This is called this is called circumcircle. Circumcircle. This is called incircle. And circumcircle radius is called as outer. Incircle radius is called as inradius. How to find here? We know for finding inner radius, the center can be, it is nothing but point of internal bisectors. What is internal bisectors? Which is divided this angle equally. So 60 degrees internal bisect is 30 degrees here. So take 30 degrees. And this is called as inner radius. This x is called inner radius. And if I divide this side into two equal halves, so one side it will be a by 2, this side it will be a by 2 here. Now this is 30 degrees. So in order to find this, what I can use is tan 30 degrees is equal to this divided by this. So this is tan 30 degrees is equal to x divided by a by 2. You have to find this x value, this in radius value. So this x is tan 30 is 1 by root 3, x is equal to a by 2 root 3 here. This is called inner radius. So that is the inside circle with radius r is called as inner radius. Now the inside circle in radius will touch at all midpoints. Always remember this. Whereas now the outer radius, this is called as circumcircle and it is touching at all the vertices. This is called as circumradius, circumcircle, and its radius is called circumradius. Now if you see here, this is your circumradius. So this y. And which is touching midpoint, this is in radius, which is touching its vertices, this is called circumradius. Let me assume it as y here. And you know this is a by 2, again it is 30 degrees, same 30 degrees here. So in order to use this, I will apply cos 30 degrees here. Cos 30 is equal to a by 2 by y. So a by 2 by y. I have to find y here, so y will go here, cos 30 will go there. So now 2 get cancelled, a by root 3 here. Now, what is circumradius? Circumradius or outer radius is equal to a by root 3 in equilateral triangle. Whereas for in radius it is a by 2 root 3. If you observe it carefully, the circumradius is equal to 2 times of in radius here. That is why it is called this. It is a by root 3 here. It is a by 2 root 3. So both because a by root 3 becomes a by root 3 here. So this is a relation. Circumradius is equal to 2 into in radius here. So if you observe it carefully, this is called median. As I said already, the median for centroid will divide this median into 2:1 ratio. So here 2 is nothing but circumradius and 1 is nothing but in radius. So circumradius by in radius is equal to 2:1. So take this in radius here, circumradius by in radius is equal to 2:1. So even you can apply this medium to get this value and that method to find the circumradius and in radius here. If you observe it carefully, wherever equilateral triangle, that is for finding area, in radius, out radius, we have root 3 common here. Whereas in the area of equilateral triangle is root 3 a square by 4. Here it is in radius is a by 2 root 3. Here out radius is a by root 3. So root 3 is common here. Okay. So try to learn how to find out. Though if you forgot these formulas, how to find out these formulas. Right? This is for equilateral triangle.
Please subscribe to my channel Connecting Minds and please share link with your friends. Jai Hind.